How are we going to decide if we have a Poisson distribution? This is important when you're sitting NCEA level 3 probability distributions. You're not told which distribution it is. So I'm going to give you some tricks to help you remember. Let's get started straight away. Okay, the first thing we're going to ask is this question a Poisson distribution? Right? And I'll give you the technical language for it. It's a discrete events occurring in a continuous but finite interval of time or space. Now, that's probably a little bit hard to remember, so I'm going to introduce you to this cat here. This cat loves whole fish. If she gets some, she will purr continuously. So what you need to have in your head is discrete purr continuous. Can the average for this these events be stated as discrete per continuous? So let's have a look at some examples. So the examples here are I've got two. Never mind, we'll go through the first one first. The number of faults in a fiber optic cable per kilometre. So number of, right? Straight away discrete, yes? So where we see number of, obviously we're talking something that's counted, therefore it's discrete pretty much by definition. Just quickly thinking, you can't have half a fault, can you? So yeah, definitely discrete. In a fiber optic cable, per kilometre. So there we see the per, so we think of the cat straight away. Now if you see per in a question, it doesn't actually always mean that it's Poisson, but it's a pretty strong hint. So it is possible to have per in another question, but it's worth putting money on it being a Poisson. And per kilometre is obviously a continuous measurement, so let's think of some other continuous. Look, there's an example underneath. Year, so time is a continuous measurement. So if we look at the second example, the number of volcanic events at Ruapehu in a year, or the number of volcanic events per year, you could have said it as. So try restating the question in your head. Does it make sense with per in there? Okay, because remember we're talking about a cat who, when he gets whole fish, by discrete per continuous. Discrete per continuous. So the number of volcanic events, that's discrete, in a year is per continuous. So that's good. Both of these are good. Now, at least on this criteria, we're going to look at the conditions later. How many mosquito larvae are in a bucket? 5 litres of pond water. Now, if we were counting buckets, that's discrete, right? But it's 5 litres. So if we were suddenly talking about a 10 litre container, or a 1 litre container, or 50 mils of water that we'd taken out of there, we're talking about continuous. So yeah, no, that's fine. That's continuous. How many mosquitoes? Well, you're not going to get half a mosquito. Well, not a live one anyway. So therefore, it's discrete per continuous. Now notice it's are in a bucket, but we could say how many mosquitoes per 5 litres of pond water. Absolutely, definitely something that we'd be thinking of as a potential Poisson distribution. Right, number of particles emitted by a radioactive sample each minute. Okay, number of particles emitted by a radioactive sample each minute. So there's either a particle or there isn't. It's a discrete thing. It's the number of again, and a minute is a continuous measurement, right? So notice we've had length, we've had time, we've had volume, and now we've got time again. These are all continuous measurements. These are measurements. Yeah. Okay, customers arriving at a checkout. Yeah, don't have half customers or third customers or whatever. During a 15-minute interval. So clearly 15 minutes is a time measurement. So yeah, very good. Excellent. Okay, all discrete per continuous. So let's go on to the actual conditions. Now the conditions that they will want you to talk about if you're trying to justify using a Poisson, the main things are independence. The events have to be independent of each other. The events cannot occur simultaneously, either in space or in time. The events must be random and unpredictable. Okay, if the customers are arriving at regular times for some reason, then it wouldn't be applicable, and it needs to be proportional. So the number of occurrences need to be proportional to the length of time or the volume that you're measuring, or the length. Okay, so that if you double the length, you're sort of expecting double the number of faults or whatever it is that you're measuring. Okay, so my cat is called Sir P, short for Sir Poisson, and so each of those letters helps me to remember something about the conditions, right? So S is simultaneously. Events cannot occur simultaneously at the same time or the same place. I is for independence. Each occurrence is independent of other occurrences. R is for random, obviously. Events occur at random and are unpredictable. And P stands for proportion. For a small interval, if we're going to be technically correct, we must say this. For a small interval, the probability of an event occurring is proportional to the size of the interval. So if, in the previous question we were talking about number of customers in a 15-minute interval, what we say with Poisson is that if you want to know the number of customers in a 5-minute interval on average, the average will be a third of what it was for a 15-minute interval. That's what we mean by proportion. So if you double the length of the time and talk about a 30-minute interval, then we're going to double the average, and that will be our new average. Okay, so Sir P, Sir Poisson the cat. Okay, I hope you've enjoyed this, and you may also want to watch my binomial video, yeah, good luck.